next problem is called subsets 2, and it's basically the same problem that we had before, subset 1 you can call it. And the only difference here is that the input array that we are generating the power set for contains the duplicates. And the solution that we are returning must not contain the duplicate subset. So we will be using the same logic, but there's a slight modification, a slight trick that we can use to make sure that we will not have the duplicates inside the final result that we will be returning from the function. And when you think about duplicates, the first thing that you should pop in your mind is either to have a hash map so you can track if you have already seen that element, or sorting so you can easily detect if the adjacent elements are the same, if the adjacent elements are duplicates. We will choose sorting for this problem. And if we sort an element, and if for example, if we have a sorted element 2, 2, and I will just, for the example, x epsilon set can be any number, and larger than 2 in this case, but this is a sorted version of some input array that we have received. Now, if we do the subset generation without any tricks, basically we are allowed to take the second element if it doesn't matter if the first element has been selected or not. What will happen, we will have the generation of the duplicates inside the final result. And let me show you how they will be generated. So in the first example, maybe we can choose to have the first element not selected and all the other elements selected. So the set that we'll be adding will be 2x, x, epsilon, and z. So we basically allowed to select the second element, which is a duplicate, we know, because in the sorted order, the previous element was the same. So we allowed it to be selected even the previous element that's the same hasn't been selected. So in this case, we will have this. And in the other scenario, we will select the first element, but not to select the second one. And we will basically receive the same output. So this entry will be duplicated inside final output. To prevent this, the only case where we should allow for a number to be selected is if the previous number wasn't the same. In that case, we will have distinct generation of subsets, or if the previous element is selected. In this case, we will have so in this case we have 2 and 2, which are duplicates. For the first number, we can either select it or deselect it. If we select it, we will have 2 and then two possible outputs for the second one. We can either omit it, so we'll have 2 x epsilon z, or we can select it. We will have 2 x epsilon z, and so we can only select it if the first element was selected. Third scenario, if we don't choose the first 2, we cannot choose the second one either, because if we choose, we will generate duplicates. So in that case, we will just have x epsilon set, and this will be distinct subsets inside the power set. So basically, the trick for preventing the duplicates is to sort the array and to disallow elements to be selected if the previous element is the same and hasn't been selected. Or if you have a regular scenario where adjacent elements are not the same, basically we have a sorted order, and for example 4 and 5, we can just follow the same procedures as we did in the generating subset 1 without duplicates. Just as we had in the subset 1, we will start by declaring our result, which is list of subsets, the power set that will be returning as the final output of our function. The modification that we talked about is that we will sort the number so we can easily detect if we have duplicates. And then we will just call the helper function. We'll get to the helper function definition and signature later. We will basically just at the end return the result, just as we did in the subsets 2. Now for the helper function, it's basically the same as in the subset 1. We have the index, the set of candidates, the current list the set that we are currently generating, and the result that we'll be returning from the main function. The only difference is that we additionally have a Boolean that will be changed depending on whether the previous element has been selected, whether the previous call of the helper function included the element to be selected. Now, we'll proceed by declaring the base case. It's basically the same as in our subset 1. We will just check if the index is out of boundary of the nums. That means that we have no longer candidates, and we will just add the current generation, the current subset to the result. Next, we will basically we have two options. The first option here is to not select the element, so the boolean that we are passing will be false. The second option is before we go to the second option, we first have to check if the elements are adjacent, the current element, if the elements that are adjacent are the same, if the current element is the same as the previous one, and if it is, but the previous element wasn't selected, the element selected Boolean flag is set to false, we will return. We will disallow to select the current element. If not, we have a regular scenario, and we will basically add the element at the current index to the subset that we are generating, and we will then recursively call helper again. Important to not forget to backtrack, so we have to remove the element that we have added before, after we are done with the recursion, after we are back from our recursion calls. The important part here is that intentionally we switch the order of the option, which basically means that it's not important as long as you do the correct backtracking. So in the first problem, subset 1, we first selected the number, we recursively called helper, and then we backtracked and called the again we called the helper function, which basically means the second option. We didn't choose the element. In this case, we go with we don't select the element as the first option, and then for the second option we select the element, and then we do the recursion, and after that we do the backtracking. The important part is that if you select an element and then call the recursion, it's important to backtrack after the recursion is done.